Okay, so when we left off last time, we were talking about extinguishing agents. What are kind of just real quick, what do extinguishing agents do to help basically put out fires? Yeah.
Either displace oxygen or
Okay, so they can displace oxygen, separate the oxygen. What else? They can cool it. Yep. Anything else? You can take away the fuel. You can separate the fuel from the flame itself, right? If it's the type that creates like a coating. And then we talked about different types. Some of these do that, some of them don't. Water, for instance, on oil does not. So water is usually used for where did I say water is used? Anyone remember? There's kind of one. It's used in the cabin as primarily for trash can fires in case of a cigarette being thrown in there. It was usually the main culprit. Okay. And then dry powder isn't used much because it's really corrosive. But we talked about halon being one of the most common for areas that are not accessible, cargo compartments, engines, APUs, right? It's halogenated. Halon is short for halogenated hydrocarbons. These are oxygen displacing. So they do a little bit of cooling as well, minimal, but primarily it's to evacuate, it's to push any oxygen containing atmosphere out of an area in order to separate oxygen from the fire. That being the case, one thing I did want to mention, what is important about a system that uses halon? Importantly, the area where we're going to be deploying halon to put out a fire. If the way it works is by pushing oxygen and air out. What's that? Well, you don't want it to be passenger. We don't want to kill the passengers by suffocating them. Okay. It can be pressurized. Cargo compartments are usually pressurized. What's that? So lithium batteries, it actually can react with lithium and make them more flammable, or can increase the severity of or the intensity of the fire. Okay. So the big thing is we have to have an enclosed compartment that we can snuff the air out of, that we can push the air out of. So you have what are called around engines, APU, you have what's called a fire zone, areas that are blocked off by firewalls and cowlings and enclosures so that we can fill that space. And they're fairly well sealed. Even things like engine cowlings have rubber seals around the gaps and things like that, and that's to be able to contain the halon once it's put in there. Cargo compartments, after we put together a cargo compartment, a lot of times there's like fiberglass panels, and we screw them in, and then after you're done screwing them in, has anyone seen inside of a cargo compartment? What do you see everywhere? If anyone's ever looked in an airplane cargo compartment? Has anyone ever looked in one? So if you look in an airplane cargo compartment, you will see tape over every seam in the panels and basically covering every screw and everything else. And it's a white tape. It actually has the FAR number on the tape. It's printed on the tape that it complies with. It's almost like a duct tape. It's a tape that's got like an embedded, some kind of an embedded mesh inside of it, like duct tape does. But it's not duct tape, it's actually fire rated. So we have to make sure we seal those compartments. Other ones do use like sealant, like RTV as well. But the tape is the most common because it's quick to replace, quick to install. It also means it's quick to remove, which sometimes rampers and other things, bags will catch on it and stuff like that. So, but it is part of the fire seal. So we've got a same thing with CO2, any kind of inert gas that we're going to put in an area, it has to be a sealed compartment. So looking at extinguishers, what we're gonna have. So on board the aircraft, we're gonna have portable extinguishing systems. So here's some examples. The one on the left, this is a water fire extinguisher. So that's what you're gonna have near the lavatories and galley for trash fires. And then on the right here is a portable halon bottle designed to be discharged into an enclosed space. Okay, typically portable halon bottles like that they can be used. They'll be used as well in like a trash can area if you can discharge it into the trash can without having to open it up. Because most of the trash cans are inside of an enclosure. That's why they're in there. But these are available to flight deck crew, cabin crew, and they can be any type, halon, CO2, some are dry powder, and then water. Dry powder is usually There may be a dry powder one available for like if they have a galley where there's going to be any kind of cooking or food prep, which is very rare nowadays, more so back in older aircraft. Nowadays, everything's like, basically just warm up the pre-prepared food, so there isn't a big risk of fire in the galleys, but
Fire risk basically at that point's electrical.
there can be electrical or there can be materials that can catch fire, if something goes against the heating element or something like that. Again, even like the ovens, though, are sealed. They're a locking door oven with a seal. So hopefully, if you do get a fire in there, it'll consume the oxygen and burn itself out before it can spread anywhere. So there's different classes. You've probably, some of you may have seen these before. So A is your ordinary combustible materials. Type A fire extinguishers are made for those. So things like wood, paper, etc. So the water fire extinguisher here is a type A extinguisher. B is flammable liquids. That's your greases and your oils. Okay. C is your electrical fires. Okay. So if you have a fire extinguisher at home, it's probably an ABC fire extinguisher. It uses dry powder and it's good for ordinary combustible materials, flammable liquids, like a kitchen fire, or to some extent electrical fires as well. Okay. Type D are specialized. These are for flammable metals, but they're not the same dry powder that's used for other stuff. Flammable metals, magnesium, alloys, aluminum dust, stuff like that can be very difficult. Even steel dust can be very difficult to put out, so you have to have special materials for that. Installed, so in addition to the portable bottles, then we're going to have our permanently installed systems that look like this. So here's what your typical enclosures look like. They're kind of either spherical or some of them are a little more oblong, egg-shaped. It's not really egg-shaped, more like a pill, or they the best thing is they look like a minion. Rounded on the top, rounded on the bottom, a little bit cylindrical in the middle. But these are for your engine compartments, APU, cargo and baggage. And then even the lavatory, again, the trash can in aircraft also, in addition to that portable water extinguisher, a lot of them have a little tiny, like fist-size halon bottle that's mounted right above the trash can that can automatically discharge if there's a trash fire. So they look like this. Just some of the things you can see here. Here's the outlet. They have pressure gauges on them, so we can check the pressure of them. In order to activate them, we've got wires coming up right here at the outlet. This is a explosive squib. So that explosive squib, when you put a charge on it, it basically shoots a little projectile up into a breakable disc, what's called a frangible disc, that pops open the bottle to allow the halon or CO2 to escape into the area that it's going. So these are pressure, pressure holds the agent as a liquid when you pick one of these up. First of all, they are much heavier than you would expect. Halon is a very dense liquid. And you pick one of these things up. One of these bottles this size, which is probably about that, sometimes can weigh upwards of 60 pounds for something a little bit bigger than a basketball, right? And so it's almost like medicine ball size, right? So if you pick one of those up, if you kind of shake it, you can feel the fluid sloshing around in there. So under pressure, it's kept as a liquid, but as soon as that frangible disc bursts and it's allowed to escape, it instantly turns, it turns into a gas in order to fill the space. So it can fill a much larger volume than what it's stored in, right? You can fill a whole cargo compartment with a few of these bottles. So then, in addition to the liquid, by putting it's a liquid that at room temperature it wants to be a gas. Okay, at room temperature and room pressure it wants to be a gas, but to help boost the effectiveness, boost the ability for it to discharge from the bottle, the space, the air space in there is filled with pressurized nitrogen as well to help increase that pressure and keep head pressure on it to make sure it stays a liquid and to help discharge it. And that's typically nitrogen because nitrogen's being inert, right? We wouldn't want to put oxygen in there and pump any oxygen. That would kind of defeat the purpose. So it's going to be pure nitrogen. And then but they will change pressure. One of the things we got to know is they have pressure gauges on them, but the pressure will be directly dependent on temperature. So the warmer it is, the higher the pressure will read in the bottle. The lower the temperature, the lower the pressure in the bottle. And if they get too hot, they do have the potential to get a high enough pressure that it could become dangerous. And so they have a pressure relief on them, some kind of a blowout type plug that will basically pop open if the pressure exceeds a certain level so that the enclosure itself doesn't burst. Yeah.
Halon try to disperse all gases, or is it just oxygen?
Well, it just fills a space, right? So anything that's in there gets pushed out, and it's very dense, so it's gonna push, less dense air, nitrogen and oxygen and whatever else, right? The two primary elements that make up air. It's gonna push that out. Okay. It doesn't mean it necessarily, there may be some that stays mixed in a little bit, but the key is we're getting that we're getting that atmosphere to a low enough oxygen content that we get below that stoichiometric ratio. And so even if there's a little bit of oxygen left there, if it's below the stoichiometric ratio, the fire, it's not going to be able to burn. Right. So they do displace almost all the oxygen, but it may not get every single last oxygen molecule out of the area. It's enough that, it'll put a fire out. It's enough that, one of the cautions with these is if you're working in a cargo compartment and one of these things are activated, you want to get out of the cargo compartment because it can suffocate you. It's enough that if animals are in the cargo compartment when the aircraft is in flight and this is discharged, it's going to kill whatever animals are in that cargo compartment, right? So, they are very effective in that regard. We do have a halon system here, by the way. There's one in the sim bay. So if you look at the sim bay, it says if there's a fire, get out of the sim bay. And it's because halon systems are often used in like data centers, computer areas, because again, it's non-corrosive, it doesn't hurt the equipment, right? And it'll eventually dissipate. But if you're working in an area that has a halon system, and they usually have a time delay where you need to get out of there before it begins to discharge. Aircraft systems don't have a time delay. They go in there, there's kind of an assumption you're not sleeping in the cargo bay, right?
Fire as soon as possible.
Yeah, so actually you don't necessarily. Sometimes you can put the fire out just by cutting off the fuel source or turning off the ignition. That's the first step. So you don't want to discharge these right away, particularly like an engine. So our normal procedure, if you got an engine fire, was the first step was to arm the system, and arming the system would close any fuel valves, it would close the air valves, it would close any oil valves, it would close any valves for the hydraulic system. So that cuts off your fuel source coming into the engine bay. And then you have that enclosure that's fairly well sealed. So if there is a fire, you give it some time. That fire may just burn itself out. It may snuff itself out from lack of oxygen, right? Because the fire itself is producing carbon dioxide. So we would arm. Our procedure was to arm the system, which effectively cut off fuel. It would shut the engine down, so that gets rid of an ignition source. And then you would wait for a period of time, 20 to 30 seconds, before you actually discharged the fire bottle. And then remember, one of the requirements of a fire system is that it indicates until the fire goes out. So if you arm the system and you get that indication that the fire has gone out, you don't have to deploy your bottle. In fact, you're told not to, because if for some reason that fire reignites, then you have the bottles available later to fight it. With any engine in it, for instance, there's 2 bottles that can be used on each engine. If you deploy one, you do not deploy the second one right away. Because again, if the fire reignites, you want that second bottle available later on, right? We did have a mechanic one time, they got a fire warning, and they basically pulled the handle and went boom, boom, popped both bottles right away. They realized it was a false alarm after the fact. That's an expensive fix. Yeah, these are, I can't remember how much they were to recharge. It depends on the size of the bottle, but anywhere from $10,000 to $50,000 to recharge them. So, plus the squibs, the explosive squibs and the frangible disc, and you have to get them hydrostatically tested and everything else. There's no damage from it. That's the point of halon. It doesn't do any damage. So these are stainless steel or titanium. Most of the ones on civilian aircraft are going to be stainless steel, although sometimes if weight's really a concern, things like weight and balance, they'll build them out of titanium to make them lighter. But titanium bottles like this are incredibly expensive, so they try to do stainless steel if they can. Here's a squib right here. So this is the electrical cannon plug on the left. Here's the projectile on the right. Okay, and that is aimed at a disc like this. This is the disc on top. that is holding the halon in the bottle, or the CO2 in the bottle. And so when an electric charge is applied to this squib, this thing at the end comes out, it hits this frangible disc right here, causing it to fracture and break apart. And then whatever gas is in the bottle can discharge. There's a strainer, like a screen downstream of it, so we don't send the chunkies down to the engine or the cargo bay or wherever, right? The squib and the frangible disc chunkies all kind of stay in the strainer. And then, here's the squib down here pointed that way. And then the gas can go out through the discharge head, and then it usually goes through some piping to wherever it's needed. Okay. When one of these bottles discharges, we want to be able to know that it's happened. So one of the things is these often do have a pressure switch on them. In addition to the squibs, there's some wires going to a pressure switch, and that will either turn on a light or provide an ICAS message or ECAM message in the flight deck telling you that there's low pressure in one of the bottles. That's the caution you get, as a low pressure bottle, low pressure caution light or message. However, to be able to see from the outside of the aircraft, on many aircraft on aircraft on the outside for these bottles, for each bottle, there are going to be these two little kind of discs, and they're maybe the size of like a penny on the outside of the aircraft. Some of them are a little bigger, some of them are almost an inch in diameter. But you can see we've got, and it's just a little port. It comes off the bottle, and then there's a little plastic disc that gets installed in it, and it's just kind of a friction. You just kind of push them in. And so the little hose running to the back of it, if the bottle is discharged, it will pop that little disc out. It'll blow it out. So it's called a blowout disc. And there are two colors. So you've got red. Red tells you you've had a thermal discharge. So that is the bottle got too hot, the pressure increased to a point where it wasn't safe to be contained anymore. And so that overpressure discharge activated. Okay. The other one, the yellow, is an activation discharge. So if the bottle was activated for some reason and sent the halon into whatever bay, cargo bay, engine bay, APU bay, then that yellow disc will pop out. So part of a typical walk around for a flight crew is they know where these are located on the aircraft. Often, twin engine aircraft is usually in like the pylon areas, or if they're tail mounted engines, they're back in the tail. There's usually one for the APU as well, the APU fire bottle. And so you'll know where these are at as part of a walk around before you either taxi the airplane as a technician, or before a flight crew takes the airplane to fly. One of the things they'll look for is to make sure these discs are in place. Now, the only time I ever replaced the discs was because one just happened to fall out. So if you find one that's missing, then you go up in the flight deck, you power on the airplane, you're like, okay, the low pressure light is off, or the low pressure message isn't present. Or you go back to the bottle and you look at the pressure gauge, you're like, yep, there's pressure. It probably just worked its way loose and fell out during flight or something like that. Or, maybe there was a hard landing and it knocked them all loose or something, along with all the passengers' teeth. So, really you do a quick check and they tell you if the bottles are good or not. Okay. To activate these systems, oftentimes you either have a set of buttons or a set of handles. So up top is some glare shield buttons that are on some aircraft. Down on the bottom here are pull handles. Boeing uses the pull handles. Newer Boeing aircraft, the pull handles are down on the center pedestal, typically right behind the throttles or near the throttles. Older Boeing aircraft, they're usually overhead. Okay. And then, like I said, the push button ones this is the glare shield. So your main displays are right below them. And so you're going to have a two-step process to discharge your extinguishing agent. And so the first one is you're going to, if it's a pull handle, you're going to pull the handle. Okay, you're just going to pull it straight up or pull it straight down if it's an overhead. If it's the push button, you've got an arm button, and typically, so you've got, like, these are the engine ones. You've got a left engine arm here. You've got a right engine arm, and actually this is an APU arm right here that doesn't have the box around it. Okay. And so what'll happen is if there's a fire or if there's a vacation, you'll get a master warning or you'll get a fire warning depending on the aircraft. Some have a unique fire warning. A lot of them, it's just part of the master warning. So, which is red. And you'll get a fire bell, and you'll often get, newer aircraft is left engine fire or left engine overheat or left jet pipe overheat, right? You'll get some kind of an audible, spoken audible. And then like here, you can see all three of these handles are lit up on the Boeing, right? Well, they're probably doing a test right now. They're doing a light test. You can see all the lights are turned on. So they're doing a light test to get those to light up. But if you have an actual fire, only one handle will light up. And it'll be the handle for the location of the fire. Same thing with these buttons here. If it's the left engine button will light up. Right engine button will light up. Or APU, the APU button will light up. So that's to draw your attention to the location, because you don't want to have a fire on the left engine and pull the handle for the right engine and shut it down accidentally, right? Probably aren't going to have a good day at that point. So you arm the bottle. That's going to close things like your fuel valves, your air valves, your pneumatic system valves, because at that point you don't want to be sending smoke into the flight deck, into the fuselage, right? Hydraulic, where there's a hydraulic pump, there's going to typically be a shutoff valve. Not so much because the hydraulic pump sending fluid out is a problem, but there's pressure in the system, and you don't want fluid being forced back up towards the engine from the system pressure as a fuel source, right? Hydraulic fluid can catch fire. It's an oil. And so that then not only does it acknowledge the fire, and you tell, you pull the handle or push the button for the engine, that tells the firefighting system where you want to discharge your extinguishing agent. And so, because most aircraft, twin engine aircraft, have two fire bottles. And they have two fire bottles. Usually one is near the left engine, one's near the right. But they are plumbed in such a way that you can route that extinguishing agent from both bottles to either side. So when you pull that handle or push that arm button, that tells the aircraft, I want you to send the extinguishing agent to the left engine, or I want you to send the extinguishing agent to the right. Most aircraft, the APU has its own fire bottle, and it just usually has one, not two. Okay. So we either pull the handle or we do these. One other note on the Boeing style, these handles actually have a interlock on them. So under normal circumstances, if they are not lit up, you cannot pull the handles. They're locked in the down position. When one of them lights up, it also unlocks a solenoid that releases the handle. If that does not work, it's really hard to see, but you can kind of see it here. There's a little button you can see underneath the APU and number 2 handle that you can push to release the handle if for some reason you can't pull it. Or for a lot of times we would test it to make sure all the valves close and everything. You would push that little release button and pull the handle. Okay. The next step then is after you've armed it. So on these push button style, then these lower buttons will light up, and these are the actual discharge buttons. And there's a discharge button for the left bottle and a discharge button for the right bottle. There's also a discharge button for the APU bottle. So those will both light up. On the handle, you can see there's a discharge L or R. You can twist the handle one way or the other, and that tells you which bottle you're going to discharge. So there's a fire indication, you pull the handle, you're going to wait a period of time in order to see if just cutting off the fuel supply and possibly the ignition source by shutting the engine down, does that make the fire go out? Right? If it does, great, you don't discharge the bottle. But if it doesn't, then you're going to discharge one of the two bottles. So you'll turn your handle, say, to the left or to the right, right? Or you'll push the left button here, and you'll push the right button there. But you'll just do one of them. And again, then you will wait a period of time, and you will see if a single dose of fire suppression is able to put the fire out. And then if that doesn't happen, then you will either twist the handle the other direction, or you'll press the second button. Now, when you press these buttons, remember I said they lit up when you arm the system? When you press it and the pressure in the bottle drops, they turn off. So you know that bottle is no longer usable. Plus, you'll get a message on ICAS or a light if it's an older airplane that says, say left bottle low pressure. Tells you that bottle is no longer usable. Okay. So they can be discharged independently. They send that charge to that squib, it bursts the frangible disc, and the agent flows to the location of the fire through various ducts and pipes. So when you look at, the physical location that you have the handle, and then you get a low pressure, we think. So like overheat, we want to thought somewhere there's a low pressure light, right? Well, like here's the APU bottle discharge light at the bottom. I don't know where the engine bottle lights are. I think it might be that one there. And that's wheel well, fault, APU. There's probably a couple more there. So you'll get a light and you'll get an ICAS message.
Fire and ended one, discharge the left bottle. You just leave it on the left one.
You would just leave it until you're ready to do a second bottle if need be. Yeah. They're usually connected to the hot battery bus. So your batteries are connected. The hot battery bus means you can't shut it off. If the battery is actually plugged in, it's getting power from the battery. So these systems are one of the few that are connected directly to the hot battery bus. So that's a good point. Often there aren't breakers you can pull for these. Sometimes there are, sometimes there aren't. Usually there are. Actually, I take that back. There are breakers, but they're not like one of your main breakers. They are specific breakers for this system. So if you are working on these, make sure that you deactivate it. And it may be you have to actually disconnect the battery, the cable that goes to the battery in order to do that. Yeah. Some aircraft only have one, like the battery usually is like a lot of the aircraft. So like the CRJs and the Embraers, they have a APU starting battery, and then they just have an aircraft battery. They don't have like two batteries that are an emergency. One's not an emergency, but they both feed into the battery bus. So in a way, there's it's got a fall over if there's like a diode setup in there, everything that makes sure that battery, what's called the hot battery bus, not the main battery bus, but the hot bus always has power to it as long as the battery's hooked up. And if AC power is working, you have a transformer rectifier that's always feeding into that bus as well. So here's what they look like. The two fire bottles for engines. Again, we're looking at engines right now. 2 discharges per engine, but not necessarily 2 bottles per engine. So if you, the idea is the chances of needing to having a dual engine fire is pretty low. So if you discharge both bottles into one side, hopefully you don't need fire bottles on the other. I mean, at that point, the fire's the least of your worries. You're trying to just get the thing on the ground now, right? So that's extremely low, but you do it. And so here's this is one way that it can be done. So the bottle can have 2 discharge ports, right? Here's that relief valve at the top that goes to that overboard blowout. If the pressure's too high, there's your pressure gauge, and then this has a switch to the low pressure light. But, if I've armed it, you can see that I can send, to the number 1 engine from here, or from the right bottle, I can send to the number 1 engine. They tee together. I can send to the number 2 engine. Sorry, number 1 engine here, or the number 2 engine here. Okay. These are this is the wiring. And then, we can send stuff to the number 1 engine, or from either bottle, we can send halon to the number 2 engine. Okay. Some aircraft have a style that looks more like this. And so here you have 2 bottles that tee together. There's check valves in here. This is like, they call it a dual check valve where they tee together. And when you pull a fire handle, now this is a 3-engine aircraft, there are valves. You can see 3 valves. So when if you pull the number 1 fire handle, it's going to open the valve for number 1. And then when you discharge the bottle, it's able to flow to the left. If you discharge the other bottle, it can flow there too. Okay. So just 2 different ways of plumbing this all together. These just you can see a single port coming off the bottles. This style, you have to have 2 ports coming off the bottles. And so that's that's your engine system. So again, we have 2, the key point is we have 2 bottles that are available to discharge into one of the engines. Okay. Cargo areas also are going to have, halon bottles like this or gas bottles like this. So these but not all cargo areas have them. So cargo fire bottles are used in what are called Class C and Class F cargo compartments. So there's different classes of cargo compartments. And if you really want to read the details of them, here's the link. It's 14 CFR 25857, right? 25 being your transport aircraft design. And they're going to work in conjunction with your smoke or fire detection system. So Class A cargo compartments, these are if a fire can be discovered by a crew member while at their station. And it's easily accessible in flight. What's an example of a Class A cargo compartment? You've probably all used one. Well, those of you that have flown. What are you pointing at? The overhead bins are classified as like Class A. They don't have fire extinguishing in them. But if all of a sudden smoke starts coming out of it, passengers, flight attendants, right, are probably going to see that, and they can grab one of those portable fire extinguishers and access it in order to put the fire out. Class B, these have smoke and fire detection. So here is the crew standing at one point can extinguish the fire anywhere in the compartment without entering. And they have to have a means to prevent smoke and flames from entering the passenger crew compartment. What is this? Where? What's that? Nope, not the bathroom. Have any idea where you would have one of these? Do you think you would have one of these on a passenger aircraft typically? So aft baggage is tied to the cabin. It's more so like if you have a freighter where you have the main deck that's right behind the flight deck. Did you all go in the 727 when we had it? No, kind of. Some of you maybe yes, some of you no. Okay, so that still had below floor cargo compartments where baggage would have gone if it was passengers. But the main cargo compartment was, basically take all the seats out. Now you got a long flat deck and put a big door in the side. This had the ability, a lot aircraft have the ability where the crew, the flight crew, is able to fight a fire that's occurring. There was no fire suppression system built into what's called the deck of the aircraft. Okay, what would be the passenger area. But what they had is there were a couple of large portable fire extinguishers that were kept in the flight deck. And then there was this little port at the back of the flight deck. And if there was a fire, they had a smoke and fire detection system. And if they got an indication that there was a fire on the main deck, one of the crew members, the flight engineer in this case usually, would get up and grab that big bottle. They would stick the nozzle into this little port in the back wall of the flight deck and pull the handle on it, and that would route the stuff into the main cargo deck. It was a very large main cargo deck, right? So there's kind of a limit to how effective it is. But that's the whole point. The crew doesn't necessarily have to enter they can manually discharge a fire extinguisher into that area without having to enter it. Class C, remember I said cargo bottles are installed in Class C and F. So Class C, smoke and fire detection, built-in extinguishing, means to prevent smoke and flames from entering the passenger and crew compartment. Anyone know what those means were? I talked about them a few minutes ago. Sealed panel with tape. Okay, so all the panels that are sealed, that's part of this Class C, and a means to shut off airflow to the compartment. That's the other thing. When you have a cargo fire on a passenger aircraft that's under the floor, usually there's ventilation run to that area because maybe you'll carry live animals or that kind of thing. Well, when you arm the fire bottles for that cargo compartment, again, the cargo compartments, I didn't show the panels, but they'll have an arm and a discharge button. When you hit that arm button, it shuts off. There have to be valves that shut off the flow of like pack air or recirculation air into that compartment. Okay? So even if you didn't discharge the halon, it's going to get real stuffy in there, right? More than likely the animals aren't going to make it. Smoke inhalation and all that stuff. What I'm getting at is probably if you really like your animals, don't put them in the cargo hold. Our 7-pound dog goes in a little carrier under the seat in front of my wife. He does fly with us. Yep, cats can do that too. But if you have larger dogs, they're going to go in the cargo compartment. It's not a pleasant experience for them. Cargo compartment E, Class E, dedicated cargo aircraft. So again, this isn't going to be on a passenger, but this is going to be these are going to have smoke and fire detection. You can shut off airflow to the compartment. Okay. They're going to have a means to prevent smoke and flames from entering the crew compartment. And in this case, the crew can access emergency exits no matter how cargo is loaded. So basically what it is, they have to have an area, it has to be able to close off that cargo deck from the flight deck. Okay, and it has its own, it has a way to shut off airflow, okay? But it doesn't necessarily have a fire suppression system. Okay? So in this case, the idea is if it's a sealed compartment and there is a fire in it, kind of the hope is that, that fire burning eventually will consume all the oxygen, produce carbon dioxide, and put itself out. Kind of a self-snuffing out type cargo deck. Suffocates itself, yep. And the other important part is that the crew can get out, once they land, the crew can evacuate. And then the last one, cargo class F, located on the main deck. So smoke and fire, means to extinguish or control the fire without crew entering, means to prevent smoke and flames from entering the crew compartment. So I'll be honest, I don't know if our 727 had a B or an F deck. There's some other specifics in there that I can't remember all of them, so I don't remember what class that was. But oh, sorry, it did not have fire bottles, so it's not a class F. That's right. I forgot about that part. There were no fire bottles, but yeah, so the crew doesn't have to enter, but it wasn't an automatic system. It wasn't plumbed in. Dedicated cargo aircraft will have the plumbed in systems. The 727 we had was a passenger conversion, so it originally started as a passenger aircraft. That was then they cut a big hole in the side and put a door on it.
Here.
Eventually, yep. So cargo fire bottles, these are typically you have one set of cargo fire bottles. You're going to have at least 2 bottles, and larger aircraft are going to have more than 2 just to get additional volume. But there's a single discharge that's shared between cargo compartments. So again, say you have a forward and an aft underfloor cargo hold, you can discharge these bottles into the forward or into the aft. The chances of getting a fire in both cargo compartments is pretty small, right? And the reason we have a forward and aft is you've got like the wings and landing gear that go through the middle of the plane, right? So usually the cargo's in front of the wings and landing gear, behind it, but there's that carry through area where you can't have a cargo compartment. So single discharge shared between, but there may be multiple bottles, 2 or more bottles that are going to discharge simultaneously, but the 2 bottles or the 2 types of bottles are different. You're going to have one type of bottle that is they call it a dump bottle or a quick discharge. The idea is to basically quickly force any air out of that cargo compartment and snuff the fire out. But we're not going to necessarily be able to get on the ground right away. Think about like an ETOPS aircraft where it may take a couple hours to get to a diversion airport. So you don't want to, eventually that halon will work its way out, air will work its way back in. We don't, if there's something that's hot or, still an ignition source or fuel, we don't want it to reignite. And so we have metered bottles, which are slow discharge, that then are gonna, for the next 3 hours, are going to slowly keep releasing halon into that compartment to make sure that air can't come back in. It creates a positive pressure with an inert gas. And those are going to keep the fire from reigniting. And so here you've got a larger aircraft where you've got 2 high rate discharge bottles and then 5 low rate discharge bottles. And they can be sent either to the forward cargo compartment or to the aft cargo compartment, depending on which valve you open. Right. So again, one set of bottles can go to either side. And here's that control panel for them. So if you get a fire in a cargo compartment, you can see there's forward and aft. You'll get one of these will light up when you get the fire warning. You press that to arm it, the armed button. And then you press the discharge button to start to activate the squibs and start the flow of of carbon dioxide or halon into your cargo compartment. So there's kind of a bigger picture of that. Okay. And again, these bottles will have pressure switches on them to tell you if the bottles aren't usable anymore. You can see here on this example, they've got the bottles mounted near, they're behind the wall in the forward cargo compartment, but there is the ability to send extinguishing agent to the aft cargo compartment. Okay. And this is kind of your most common design on passenger aircraft, okay, for those underfloor cargo areas. This regulator right here, in this case, is what slows the flow of agent going into your different areas. So I did set one of these systems off one time. Now we would have to press these buttons to test them to make sure that the valves closed and everything. What I didn't realize is the flight crew, this panel was like on the center pedestal behind the throttles. What's that center pedestal great to do? What do people like to use that for? What's that? They like to set their coffee mugs on there. And what do people like to have in their coffee? Lots of cream and sugar. And they spill them. The buttons on those center pedestals always are sticky. Like we always had sticky buttons. And so this button had actually gotten stuck in. And as soon as I pressed the arm button, it discharged the system into the cargo compartment. So, and it wasn't a huge deal. I mean, there's an expense there. Halon, we had a file, you have to file a report that you released a ozone depleting chemical into the air, which happens. And then we had to wait 3 hours for the bottle to finish discharging because you can't get in the cargo compartment to start changing the bottles when it's filling the cargo compartment with a gas that's going to try to kill you. So the plane just had to sit there hissing for the next 3 hours. By the way, it was about an hour before the end of the shift, so I was like, I'm out. This is a day shift problem. Yeah. What's that? We didn't have to vent. It's not enough. It's designed to fill that cargo space. This was a very large hangar. This was the Salt Lake City maintenance hangar. We could fit like 6 aircraft. Here's an APU bottle. Process is the same. Single fast flow bottle discharges in the APU compartment. That's sealed and enclosed. At that point, you're shutting the APU off. Hopefully, you're getting rid of any fuel or ignition source. There's only one bottle. And it's discharged similar to the engines, usually 2 switches or a pull and turn. So arm discharge or pull handle turn. Okay. Here's a lavatory waste fire bin bottle. This is a little tiny, this is that one like fist size or maybe a little bigger. Has halon in it. These tubes are pointed directly into the waste bin. The waste bin is a sealed compartment. The little door flap has to close on your waste bin. You know, the one that's really annoying to shove the paper into because it's really hard to shove in on the airplane. You're like, I don't want to touch that nasty thing. It's made that way for a reason. So it seals shut so that if you get a fire in there, there's little solder plugs in the ends of these tubes. They'll melt and then automatically there's no indication or anything that this thing discharges. It just melts, it dumps the halon in. So before each flight, the flight attendants go around and they check to make sure that these things are usable, haven't been activated. So the heat from the fire melts the solder plugs. What you have inside your compartment is there's usually going to be a little strip on the inside of the door that has little color changing dots. So they turn brown or black when they're exposed to heat. So before those plugs melt, it gets hot enough in there that it causes that to show. And so before each flight, the flight attendants open the little door. And if they see one of those where all the little dots have turned black, they know there was a fire and the bottle probably discharged. Okay. So there's no flight deck indication or anything like that. If the bottle discharges in the lavatory, there's a couple things you can do. Usually you can, if you have more than one lavatory, you can defer the lavatory. So you lock the door closed and basically no one can use it on that flight. Because usually you have an extra lavatory if you need to defer it. Some small aircraft only have one. If we were operating a short enough flight on one of our aircraft that only had a single lavatory, we didn't have to have an operational lavatory as long as the flight was under 2 hours, I think. Like an hour and a half or 2 hours. If it was longer than that, then no, we couldn't dispatch the airplane. So, and you know, even an hour and a half or 2 hours, that's a stretch. The gate agents would make an announcement like, hey, there is no lavatory. And this is if the lavatory was broken too, you know, or something. They would make an announcement. The lavatory is out of use. Make sure you go use the bathroom before you get on the plane. If that's going to be a problem, let us know and we'll rebook you on a flight, you know, with a working lavatory. So. Well, you lock the door. There's